Hey everyone, welcome back to my daily coding series. Today's day 83. So I'm on my Linux computer here. So let's see if this works. Okay, perfect. Yeah, so I just thought I would do on Linux today just because I've been enjoying the Linux environment. So I do Alt space, always on top. Okay, there we go. Yeah, so I just thought it'd be fun to do it on Linux. I was just kind of using this computer anyway, so I was like, why don't I figure out how to record? That way I can use a terminal if I have to. I don't know if I'll have to or not. Okay, so let's look at, oh gosh. Yeah, last time we were doing a hard stack problem. It was tricky. Okay, yeah, so let's, intervals. I don't know, I'll look at this. I've never, I don't even know what intervals means. But let's take a look. I don't know if it's like a window, like sliding window or something like that. But okay. So insert interval. You are given an array of non-overlapping intervals where interval of I is start of I and end of I. Okay. So, all right. Represents the start and end time of the ith interval. So this interval started at 1 and ended at 3. Intervals is initially sorted by the start time. You are given another interval. Insert new interval into intervals such that intervals is still sorted in ascending order by start of I, and also intervals still does not have any overlapping intervals. You may merge the overlapping intervals if needed. Okay, so the first part of just inserting it doesn't sound that hard. The part that sounds difficult would be the merging part. So it says non-overlapping. So I'm guessing that means like this start time, this end time could never be bigger than like a start time. Like we couldn't also have like 2, 4 here. All right, so let's look at these test cases. So 1, 3, 4, 6. So I'm kind of thinking it in my head like a number line. And then we have 2 to 5. Interesting. Okay, so then we would add it in. So the first step, I guess, would just be to add it maybe. So we'd have an interval 1 to 3, 2 to 5, and 4 to 6. But this now overlaps. So what do we return? Well, we merge the whole thing because this basically starts within this interval and ends within this interval. So we combine it into the start of the interval that it starts in and the end of the interval that it ends in. Okay, let's look at example 2. We have 3 intervals this time. 1, 2, 3, 5. Whoops. 3, 5. Okay, so 1, 2, 3, 5, and 9, 10. And our new interval is 6, 7. All right, so I see 6 starts within this interval and ends within this interval. Actually, that's not true at all. It's in the middle of these two. So you would insert it. So you insert it 3, 5, 6, 7, 9, 10. And then we check, is this starting time greater than the end time of this one? And is this starting time greater than, is this ending time greater than the start time of the previous, of the next? So is start time greater than end time of previous. Or should I say, so this means we're fine. If it's less than the end time of previous, then that means, so if this was 4, for instance, 4 would be less than 5, then that means we have an overlap. Also, a question is the end time greater than the start time of the next? So if this was, let's say, 12, then we would say 12 is greater than 9. Okay. Okay. And if both of these are false, okay, so we have these two conditions. So if this condition is true, then if the start time is less than, then this means it overlaps with left neighbor. It could be several neighbors, I believe. So if we had something like, let's say 6 to 7 and 8 to 9, and then we get something that, well, this is actually, so if we had, let's say 20. So let's say we just had 10 to 20, 2 to 5. Now, if this was, let's say, 11 to 21, or like 15. So 15 would just get kind of swallowed by it. Okay, let's say this was like 25. So you would say that this overlaps this. So you'd combine them and do 10 to 25. My question is, is it ever possible that this could also overlap with this interval, assuming that these intervals must be non-overlapping? Can this new interval overlap two non-overlapping intervals? Well, if we have 2 to 5 and then 10 to 20, what number could you even put here? Because you could say we could put 1, but that's not true, because we're sorting it. It wouldn't be in this position. If it started with a 1, it would actually be in this position. So in this case, it does look like it can overlap several to the right, but to the left, I'm thinking you can really only, well, okay, what if we had, let's say 20 to 22, and this was what, 11? Yeah, exactly. So it has to be bigger than this one. So we'd place it here. So I think to the left, it can only overlap one neighbor to the left. Now, to the right, I think you could have, it's kind of a different story. So imagine, so imagine this was our given intervals. And let's say we get a new interval, which is 1 to 1,000. So this would put it there. And then this obviously would overlap this and this, right? So our new intervals would just be 1 to 1,000. But yeah, so if it starts, yeah, that makes sense. So if it starts, so overlapping to the left, basically what I'm thinking is you can only overlap if you encroach on somebody else. And what I mean by that is this overstays. So this end index or this end value is greater than this start time. This end value is greater than start time. So that means when we add this, this overlaps. But we know that this must be non-overlapping with this. So like if our initial array was like 22, 25. So if we add this one here, we know that this cannot overlap with that. So by adding this, we've only caused this one to be overlapping because we've only added one. But if you add, so like right now I'm thinking if you add an interval in the middle of several intervals, basically it's the maximum is this one all the way to the end could be condensed. So it's like a theory assumption. When you add an interval in the middle of an array of intervals, it can only overlap with the interval to the left and all intervals to the right. So I'm pretty sure that's true for these examples. So if we look at 1, 3, 4, 6, right? So that looks good. And then we add this. So now in this case, 3 now overlaps with 2. And now 5 overlaps with 4. So I'm thinking what you do is just kind of like keep looping until you are no longer overlapping. And that seems like it makes sense to me. So then you would just take one. So what I would do is check, is the one to the left an overlap? And okay, so I'm having some algorithm instincts here. Okay, so first we'll insert new interval, and then we'll insert new interval, and then we'll check does new interval overlap with left neighbor? And how do you check that? You say if, I guess, is new dot start less than left dot end. So if this one is less than the end, if it's equal, I don't know. I don't know if that counts as overlapping. Okay. If they have no common point. Okay. So if it's less than or equal. Because if they're equal, that's considered overlapping. So if new start is less than left end, then we want to say so we're overlapping. So what does that mean? It means that this sequence that we're about to start, the start position is going to be left dot start. So if these are overlapping, we know that the start position will be 1, and then basically we'll just keep checking if we're overlapped. So, all right, and then we'll say, something like while new dot end is greater than right dot start. So while this one is greater than this one, we will just like delete them. So what do I do it in place? I return intervals. Yeah. So I'm thinking, then what should right become? So in this case, let's imagine we had 1, 3. I'm thinking where something has to merge several times. 4, 6, say 7, 8. So when we do this, what should we know eventually we want it to look just like 1, 6. We should also probably delete, delete left, because we don't need left anymore, because we have its start position. Okay, so then in this case, so right now we know we want to get there. So our first step is to just delete the start position, number lock. Okay, so delete the start position altogether, and then remember that start position. So delete the first interval and remember that start position is 1. Okay, next we want to check the element to the right. So we'll say, is 5 greater than this? Yes. So we will delete that. So we'll say 2, 5, and then 7, 8. So we just are going to delete it because it's overlapping, but we should remember that the end position that we found so far equals 6. Okay, and then we'll say, is 5 greater than 7? No. So the final answer should be this. So then what we're going to do is change this interval to have start position and end position. Okay, so that's the idea. So first, insert new interval. So I could probably do this with binary search. I was thinking you could just do like a linear, but you're basically just inserting something into a sorted position. I also wonder, so with these insertions and deletions, I have to actually delete I have to delete and insert intervals into the list itself, and that's kind of expensive. It's O of n just to delete something. So this looks like it'll be n squared because we can delete at most n, and every deletion is n. So I don't know if there's a better data structure, but we have to return it itself. I could maybe delete it, just get the information I need, and then rebuild it. So that would be 2n. So how would I do that? So I was thinking maybe you could have an index. So you'd say I starts at wherever you add it, and then you check I minus 1. So we also need maybe we could just have start time and end time. So if the one to the left gets deleted, then the position of the starting interval so we'd want to keep everything up until that point. So we'd want to just like keep going, and then once we get here, it's almost like a linked list. Like we want the previous one to point to this one now instead. It is almost like a linked list, and then we just like remove all of these and point to this one. I mean, so we could have like sort of do a linked list sort of structure, or we could have like a dictionary. And we could say that 0 points to 1, 1 points to 2, 2 points to 3, etc. And then we can modify this so that, let's say we deleted I minus 1. And then we'd have like head points to 0, or I guess negative 1. Negative 1 could be the head, I guess. So negative 1 would point to 0. And then if we deleted 0, then we would say that negative 1 points to 1. And then for all of these that we delete, whenever we stop, we'll just say that I, so let's say I is like 1, I would just point to like 7, or whatever one is not deleted. And then what we would do is keep calling next interval until we get to -1, like, or the end, I guess. I think we can have mixed data types, right? So we could have eventually, let's say like, 3 points to end, or like none. So it's basically just like a linked list kind of pointer thing. I've never done anything like this, but it might be interesting. Okay, so I'm insert it like a standard way. I don't even think I'm gonna use the function. I'm just gonna try to focus on this part because I think it's more cool. Okay, so we'll set I to 0, and then while I is less than length of what is it called? Intervals. So while it's less than the length of intervals, and intervals of I of 0 is less than, what if it's equal to? If it's equal to, then we should place it, I don't know if it matters, so let's see. We just have to sort it. I don't know, I'll just say less than for now. So where should equals be placed? Okay, so and intervals I of 0 is less than new interval of 0. I goes up, and then we'll say new interval dot insert, intervals dot insert So I don't expect that this will I'm not expecting to keep this. I just want to make sure. Prints intervals. So my camera is covering it a bit, but that's okay. Head. Yeah, I forgot about this. This is not relevant right now. I think everything else is comments. Then we want to insert at position I. Okay, so we've inserted it where we want. Also, if I equals length, that would be a problem, I think, because then it would try to insert. I don't know what happens if you try to insert at like the length. So if I have a equals 1, 2, 3, and then I want to say a insert at index 0, 1, 2. So it would be equal to the length. So if we insert at 3, let's say like hello. Okay, it works. What if I a dot insert? Okay, so it actually will work. Okay. All right. So in that case, this will work. So what do I want to do? I want. So should I say like, I don't know. It's weird. So should I make like kind of a linked list or something? Next interval of previous equals I. And then we would say this equals I. I'm not printing anything. Next interval. So this won't, this will just exit whenever it continues. So it says -1 goes to 0, and then we exit. So I don't really even want to exit. Maybe I want this as an if statement. So we'll set we can just do this, right? Yeah, but then it's going to try to do it several times. Okay, let me just keep it how it was. And then for the remaining, so I is still where it has to be. So then I could just say while I is less than. So we'll insert it, and then we can just continue with this process. So if we insert it at I, let me just try doing this. So -1. So the head is 0, 0 points to 1, and 1 points to 2. So that looks good. And that's after we add it. And let me see if the order looks good. I guess this whole part is not needed. Yeah, that's not needed at all, actually. Because we can just. Sorry about that. So I thought of a different way of doing it. So we know that we're always going to insert one value anyway. So we could just say next value equals like I maps to I plus 1 for I in range. So we'll start at -1, and then we want to, the last one we should map should be length of intervals We might have to do +1 because we're adding 1. So we'll do like, let me just see what that does, and then I'll add +1 if I have to. -1 goes to 0, 0 goes to 1, 1 goes to, okay. Yeah, so that's going to be fine. This doesn't look fine because it's being inserted in the wrong spot. It's probably because I have the same thing twice. So we want to say, and, what was it? Interval of I of 0 is less than new interval. Okay. Yeah, this is, I don't know. I've never done a problem like this. I don't know if it's interval of I. Yeah, I've never done a problem like this. I don't know if it's going to work. I just thought it was interesting. So, okay, that looks better. So -1 points to 0. So our starting position is I. So that's where we're going to insert. So now let's check elements to left. So let's say, well, first of all, there's a base case. So if I equals 0, then we'll say that next interval, well, if it equals 0, then what? That means we just added it. So we don't have to check to the left. So if I does not equal 0, then we will say we want to do our is question, which was this part. Okay, so if new starts, so if new interval of 0 is less than the start time of the new interval is less than intervals of I minus 1 end time. Let me just say overlaps with left. And I'm just going to keep the if structure like that for now. So yeah, so it's saying new interval of 2, so of 0, which is 2, is less than or equal to the end. So in this case, we want to make our pointer of the previous element. So like whatever was pointing to, yeah, okay. So in this case, we'll say if I equals 1, then we'll say new interval of -1, sorry, next interval. So the head will go to I. Otherwise, we'll say that next interval of I minus 2. Oh, that actually might just work if we just say next interval of I minus 2 equals I. So in this case, if we overlap, we want to set not the previous one, but the one before it. So in this case, head should go to, so like the pointer should now go to the next interval. And then of course, we'll remember that the start time equals intervals of I minus 2 of 0. So whatever we just replaced, unless if it's a -1 here, it's not going to do good. Yeah, so if it is, then we should just take this one start time. So if I equals 1, can we skip it if it's 1? Maybe able to say like, if I equals 1, yeah, so this is true regardless of what we do. If I is 1, then we want start time to just be equal to new interval. Well, we want the okay, so if I is 1, then we want, if I is 1, then what's start time? We'd still want, so if it's less than the previous, then we point it. Do we actually just want the start time? I think we want I minus 1, actually. I think we want I minus 1. Yeah, so we update the pointers and then say our new start time is going to definitely be equal to the one that we replaced its start time, because it's either lower or equal to. Okay. And then I think what I can do is just say if this and that. So what does this do? Remove it from linked list and make starting time, and remember it's starting time. Okay, so now we want to check to the right. So now we'll say while new interval of 1, while this end time is greater than the start times. So we'll say while it's greater than the start times. So we'd say intervals, I'm thinking of I of 0. So I is first equal to the intervals. So I think we should just set I plus equals 1 right here. Okay, so now it'll check the ones behind it. So while I is less than length of intervals. Okay, so while our end time is greater than the start times, we know that we're overlapping. So we'll say that end time should be equal to intervals of I of 1. So the end time that we just took, and then we'll say that we'll have like, I don't know, like next, like J. Maybe we don't even care. Maybe just I goes up. So end time. So while I is less than. So while our end time is greater than their start time, I will just go up and we'll just keep going. And then where we stop is where there is no overlap anymore. Yes, so we want to, so in this case, we'd keep checking, and then wherever I ends up, so we need to remember, like, new interval index. Okay, and then we'll just keep going up. And then when we're done, we'll say that next interval of new interval index equals whatever I is. But there is an if statement, so if let me try this and see if I get where my errors are. So in this case, we go from -1 to 1. So we skip instantly to here. And then 1 goes to 3. So 3, yes. Okay, so that's right. So there's only one element. And then what we want to say is, okay, so now we want to loop through linked list. So this is what I was talking about. So now we can reset. So now we're just going to, so how do I want to do this? While, I guess we could say like 3 in this case is, so length, okay, so we'll say like end equals length of intervals plus 2, right? So, well, no, plus 1 because we already inserted it. Actually, just the length of intervals. 3. Okay, so while, I don't know, something does not equal end. So I guess we could say current. While current does not equal end, say current equals next interval of current. So we're basically doing current equals current.next. So what should current start at? -1. So let me print current. So this is basically a linked list traversal right here. So we're printing -1, which is the head. And then we're so maybe we don't do that. Maybe we print it here. So we're printing 1 and then 3. Okay. And I also want to add here. So intervals. Yeah, so there's a couple conditions. So if yeah, okay. So actually, I think I am going to do it up here because then it won't print the end. So it prints -1 and 1. Okay. So we want to say, first of all, if current does not equal -1, what do we want to do? We want to intervals dot append. Oh, we still need the old list though. I'll just say result. No, but I mean, I could. So this uses more memory, but it is linear, so I believe. Okay, so intervals. So we'll say intervals dot append intervals copy. And so also what I want to say now is intervals copy of new interval index should be start time, end time. Okay, so we'll just append intervals copy. And then let's see what that looks like. So why is it still printing it? 1.6. What about the other one? So that looks like it's working. This one, my output is nothing. Start time. Is that because it doesn't replace it? So if it doesn't replace it, then we'll just say start time equals new interval of 0. I have a feeling we may need to do something similar to the other one as well. End time. Yep. So I think we set end time. You know, I think we can actually do the same thing. So we'll say start time. So we can set it to just new interval of 0 and end time equals new interval of 1, and then we can overwrite them later. Let's see. Current. Key error 3. All right, let me see here if I print current, what it gives me. Wrong test case. -1, 0, 1, 2, 3. So what does it think end is? Thinks end is 4. Yeah, that makes sense. So, but we don't have anything at 3? Intervals copy, what is it? 0, 1, 2, 3. So why does that fail? Oh, it fails here. So 3 leads to nowhere. 3 should lead to 4, should it not? Print next interval. So 3 should lead to 4, but it looks like it doesn't. But this one, it works. I think we probably got lucky there. Maybe I should do a +1. Length of intervals +1. So hopefully that won't mess up this one though. 1 points at 3, 2 also points at 3. Okay, that's good. And then here 3 points at 4. Okay, so now I just want to return intervals. So this should pass the first 2 test cases. Okay. Yeah, so what's wrong with this one? 4, 8. So that intersects with, it's the equal. So if it's equal, that counts as an intersection. So if it's equal, we want to continue that. Let me use this as a test case. Yeah, so the equality stuff, I never... I think there's also another problem. What's this one? If we add 2 and 3, so we will add it here. It should be -1 points to 1, 1 points to 2, 1, 5. So we want end time to be, yes, to be the max. So we add 2, 3. The end time should be 5. Is it supposed to be end time. So if we look, I starts out, I guess it never works one time because I is already I'm guessing it just gets skipped altogether. Yes, so I is already 2. So what does this mean? So we add 2, 3. We replace this one. So end time here. Should we say that? End time is the max of itself and intervals I minus 1. So if this one has a bigger end time, so like this interval just gets completely covered. Does that fix that? It does. Yeah, this was the one I was thinking of. So what if we are supposed to insert it? Well, we know based on the other test case that we just did. So okay, so it's 1, 5, and then we insert 1, 7. So based on this test case, that doesn't really help me actually. So let's see what. So this is, I just want to use this as a test case. Okay. So 1, 5, and 1, 7. So where should we put things? So what does it do right now? It says we output 1, 5, but it should be 1, 7. I guess we'd want to. Let me see where it inserts it. So, because I guess I'd want it to be afterwards. Yeah, I want it to be afterwards. So if they're the same, I want to sort it by the other one, right? Because what if it was 1, 5 and we insert, what if it was 1, 7 we insert 1, 5? So if intervals of I of 0 equals new interval of 0. So if they're the same, then there's 2 things I want to do. So if, well, there's 2 possibilities. If intervals of I of 1 is greater than intervals, so actually let's say so if the new one is bigger, then we should insert it behind. So we would say insert, I have to use tabs, intervals dot insert I plus 1 new interval. Otherwise, well, I think maybe we should do if this and this. So if they're equal and the second one's bigger, then we'll insert it in this position. Otherwise, we'll insert it just normally. Use as test case. So now I'm thinking they'll be equal, so we'll insert it 1 space behind. Okay, hopefully that doesn't mess up anything else. Right, so I'm just going to add an if statement for that one. If there are no intervals, then just return then we will say intervals dot append new interval. Still wrong. Okay, so in this case, we have to make sure that, because I could be out of range. Okay, 150. So it's good and bad because all of these test cases, I'm able to kind of just fix with if statements, but it might just mean my solution isn't great because there's too many edge cases. Okay, so in this case, 0. So that now the interval that we're adding, so we add 0615. And then, okay, end time is not being properly set. So we're assuming that the end time of the one that exists already is bigger. So the max of new interval 1. So this will handle if the end time. Okay, there we go, finally. Okay, really interesting. I'm very curious to see what other people solved it like. So I just want to verify. I'm pretty sure this is linear. Because the way I thought of doing it, where you insert and delete from a list, that is obviously quadratic. So I kind of use like a linked list sort of thing here. But yeah, everything, we just insert one time, so that's okay. This just loops through until we find it. And this could honestly be optimized with binary search. But yeah, that's linear. This is linear. This is constant. This part is linear. And this part is linear also. Yeah, so this is O of n solution. So I want to see, let me get rid of all my print statements. I'm going to submit this on LeetCode. So 1 second. What's it called? Insert new interval. I'm curious to see if most people also did it linear. I'm guessing either most people do it quadratic, but my first guess would be that most people do it linear, but a different way. And mine's a very slow linear. That's my guess, is mine is a very slow linear. Okay, so then we'll look at Python 3. And we will, yeah, I'm guessing it's a very slow, I have to sign in, sorry, 1 second. I'm guessing mine is a very slow linear. But I'm trying to think how you could do it. The problem is that it's in place. So I'm trying to think of how you could do it in place without just like deleting it and then adding it back. Okay, I'm logging in. That's my email. All right, please work. Yeah, this computer is really slow. Okay, let's try it. Hopefully. Will it work? All right. Okay, cool. So it's like kind of in the middle. Also, this computer is like insanely slow. And I'm like recording and stuff like that. But okay, yeah. So today was day 83, I believe. So thank you guys very much for watching. And I will see everybody tomorrow for day 84. This is an interesting problem. I don't know if I overcomplicated it, but it seemed like the only way to add and delete in like linear time would be to have the dictionary. But anyway, thank you guys for watching. And